Hey everybody, and welcome to Manufacturing Matters, where we talk about the trends and the technology that are reshaping the manufacturing industry. Thank you so much for joining us from our recent episode. I'm lucky enough to be here with my co-host, John Lewis. How you doing, John?
Doing great, Winn.
It's fantastic.
Glad to be here.
Right above us right now, Automate 2024 is going on, so there's around 20,000 of our closest friends who are upstairs right now checking out all the technology. But we're lucky enough to be down here with Robert and Tom from Wachendorff Automation. How you doing, gentlemen?
Doing great. Thanks for having us. We appreciate it.
Yeah, thank you very much.
Our pleasure. Our pleasure. So do me a favor, introduce yourself to the audience and then tell us a little bit about Wachendorff Automation.
I'm Tom Bako. I'm the Business Development Manager for USA. My responsibility is to help the Wachendorff team in USA, North America. I'll hand the floor to Robert for his introduction.
Yeah, my name is Robert Wachendorff, and I'm the owner of the Wachendorff Automation. We are expert in encoders, incremental and absolute encoders. We manufacture in Germany. We are around 150 people, and we do optical, magnetic, and also absolute with all the interfaces you need for the industrial market since long time, 45 years.
Yeah, as a matter of fact, I know earlier when we were up in the booth, and we'll get into the technology, but one of the coolest things was the app. I wanted you to bring the phone because they do near-field communication to be able to program the encoders on the fly,
yes,
which makes real-time configuration super easy and simple and fast. But before we get into that, you might be asking yourself, what is the most exciting thing about encoders, right? And I would understand that. This is kind of a bits and bytes episode. This is how I think of it, where we talk about something small that's in the industrial automation space, but actually has a really large impact. Something small that has a really large impact. And encoders are essentially how every machine knows where an object is, or where tracking movement, and all these, whether we're going to be tracking it as part of an assembly operation, part of a pick and place operation, just force application, actuation. Encoders are used throughout all of modern manufacturing machinery today, correct? And yes, the different technologies have different benefits in terms of optical, magnetic, other.
Yes, that's right. And we can go into details what is the difference between magnetic and optical, if you like.
Sure.
Optical are more precise, but the magnetic technology is getting better and better all the time. Mm-hmm. So there will be a point, I assume, that the magnetic will be as good as the optical one. We use magnetic with specific software inside to increase the accuracy. This is done by software getting rid of all the noises in the magnet, so then we can detect much better than others the points, the position,
right? And
then we have higher accuracy up to 14, up to 16-bit. At least.
Beautiful. Okay. And so I think you just touched on one of the through points of this discussion, which is precise motion control, right? Because without precision, we can't dial up the speeds of our operations. We can't manage throughput to the maximum. We can't approach the theoretical limit of what a process will allow. And the more precise I think that has some impact there. You want to talk a little bit about that?
Yeah. Yes, for sure. Our customers, they would like to be faster. So. Mm-hmm. All the machines need to be faster to have a better throughput, and that means the sensor needs to be closer to the process. Right. Why? Because maybe you have slip, or you have something like a play in it, and you need more information to go closer to the physical limit of the product you produce.
Can you give us a real-world example of a process, maybe a packaging process or something?
Well, for example, food and beverage. You can put the encoder far away, and then you manufacture the food. Or if you go closer to the process, you need a stainless steel housing, and you need protection for sealing and everything. Mm-hmm. So if there is something, dust cleaning and so on, there's no problem. So that's, for example, one.
And the benefit to getting closer to the process is that you don't have that tolerance stack up that introduces error into the system
yes.
that you need to compensate for?
Yeah, exactly.
Right. Now, I know back in the old days, you'd have gear-to-gear transmission of power. We're long past that. We're more, placing servos, motors right close to wherever we're applying force. But it sounds like that we not necessarily. That doesn't always mean that we have higher counts of encoders. We don't have to use more encoders in that situation, correct?
No, not really needed. Somehow maybe, but not really needed.
Okay.
It's more, if you go closer to the process, you not only have dust or something, you also have vibrations or higher temperature ranges.
Right.
So you need to design the product that it lasts long in this application. So that's the main thing.
Okay.
And for sure, if you have too many components inside, the statistic says that it has maybe earlier a problem.
Right.
So we try to reduce also the components just to have that what is necessary for the encoder to do the job over.
So that's what we were looking at here when you were showing me earlier the board, right?
Okay.
Tell us a little bit about.
Yes, that I can do. This small one is a multi-turn absolute encoder with interfaces like CAN bus or SSI or RS485, and this one is the board of it. There's no, how can I say, there's no gearbox and no battery. So we have other companies using this type of technology, which is good, but not good enough for being close at the process or being outside somewhere. And maybe I explain a little bit how it works. So the single turn is quite easy. So you have a magnet, and with a magnet you can measure the one turn. But if it comes to count the turns, somehow you need a counter. And the battery is easy. It's just back up the counts in a processor in this kind of product to have a different gear ratio, turn ratio, so that if you turn 100 turns here, for example, then it's only a short turn here inside. With our technology, it's a Wigand wire. It's a liquid magnet, and if the how can I say the magnet pole turns a little bit, then it's like a arrow and bow. The
forces built up slowly.
Yeah, the forces go up slowly, and then it turns from south to north, for example, and then there's a spark, electrical spark. And with this electrical spark, we can power a chip, which store that now is one turn.
Fantastic.
And there's a logical software with an additional sensor, make sure that it understands that it goes in the one direction and in the other direction. So all this is done by software, and then when the power comes back to the product, this information of the storage move into the controller, and the product knows exactly where it is.
So in the event of either a stoppage of the line or a power loss to the encoder, we're still maintaining our counts and know where our position is.
Yes, exactly.
So this does require some discrete power supply to it, or is it solely self-contained unit?
It's a self-contained unit for counting the turns.
Right.
Otherwise, you need the power for the chips, for the processor inside, for the software.
Okay.
And the thing is, as you can see, the board is very small, and this makes the product very robust. So it's lasts in outdoor applications as well as in indoor with vibration, temperature, and everything.
Right. Plus, it has a compact footprint, which is more and more important for highly integrated machinery, which is kind of a standard trend going forward.
That's right. For example, if you go to AGVs, they're very small, so somehow you need to mount this. So that's a good application for this kind of product.
Right.
You also have a little bit vibration in the floor, on the floor. So that helps.
You talked about food processing, for example.
Yeah.
Are there specific IP ratings you have to meet for those stainless steel
Yes. Usually we have IP67. Also we can do IP68 with an additional sealing. For the food industry, we have special sealings for the food industry. For example, we have a customer who's making fish cutting machines, and they're based on the trawler.
Like a cart moving around up
on the ship.
On the ship. Okay, yes, yes.
For example, we
Trawler,
have
yes. That's all right. Again, your English is way better than my German, so we're good.
trawler. Right?
Trawler. Yes, sir.
For example, we have a customer who's making fish cutting machines, and this machine is on a trawler, and he needs the sealing, and he needs also the IP65, and he needs the stainless steel, and also temperature, because it's, in the wintertime it's different than in the summertime.
Absolutely. And I assume since we don't have a battery in there, then that makes us your components a lot more applicable to harsh environments.
Yes, usually, we have now batteries in the car, so batteries are good in the harsh environment. But our products work 10, 20, 25 years.
Right.
So batteries are then
Obsolete.
and
the waste that doesn't occur from not having a battery is also, an environmental consideration.
yeah.
It's a maintenance issue as well. The batteries need to be replaced.
Yeah. Well, yeah,
Is that-
it needs to be replaced, but usually, but then replacement doesn't make sense in this case. Usually then they replace the whole encoder.
encoder,
Yeah.
So that near-field communication in that case makes that, we were talking earlier about how you designed this specifically so you got really fast swap outs, very fast reconfiguration, and
Yes, I can show, but I need to
okay.
stand up.
Quite all right.
I'm back.
So we were just talking that not having the battery, and you were telling me earlier that you've got an app which allows you with near-field communication to very quickly configure and swap out elements.
Yes. Well, the reason why we did this is global logistic. You ship the product all over the world, and you can combine this type of encoder millions of different variations. So we thought about to reduce this only to the mechanical variations, and then you can ship it all over, and the stock, you have less stock if you are able to configure the product at site.
Right.
For example, you are a distributor. It's also very, very easy to do, and so we thought what would be the best programming tool? Smartphone.
Right.
So this is easy because everybody has one, and as you can pay with a smartphone, you can program our product. And we added this plastic cap to have the NFC possibility, and then you have the app, and you just configure the product with all the different things you need, channels and so on, pulses per resolution and so on, and then you just put it here, and then you get the information to the encoder, and with the next power on, it's in the encoder.
Gotcha.
So now you think maybe safety reasons, somebody wants to change doing it works, so you need to power down and need to power up to do it. Also you have a pin for security, and also if somebody wants to damage the machine, he don't want to download an app and then program, he would go and cut somewhere a cable. So it's a safe method to be flexible.
Gotcha. Now, we were talking earlier how precision motion control enables faster throughput on logistics lines, production lines. You were talking specifically about bottling in that case. So that basically what we're talking about there is the ability to move as fast as possible without having that bottle tip over, which is going to cause a cleanup issue or any number of lost downtime hours. And then we were talking about the sustainability without having the battery in there, and that also allowing us to fulfill another major trend in automation, which is taking these technologies and tools out beyond the plant floor. And you were speaking specifically about the fishing trawler as a good example. Are there some other applications? I think you mentioned AGVs earlier.
Yes, the AGVs driving more inside, but we have applications outside. For example, windmills, where you measure the position of the blades.
Right.
No.
On the wind turbines, yes, sir.
The turbine
example,
cabin as well.
Yeah. For example, wind turbines, where you measure the blades for the positioning for the wind, and cranes. With the cranes, John, you said with the cranes, it's very important.
Yeah, you don't want to have a cantilever load that might cause it to tip over or sway.
Yes.
Exceed the outrigger
They can measure
requirements.
the mass of the load with a different type of sensor and the position of that and the angle of the crane hoist.
Or the extension of the boom as well is another point that you can also measure.
Absolutely.
And all these needs to be done with a small sensor, and weight also is important in this case, and all the robustness and vibration, temperature, and all this.
Absolutely. Okay. So we've talked about a lot of different ways that something small actually impacts large applications that we may not always pay a lot of attention to. And what else? Can you tell us a little bit about what the future of encoder technology? Do we have anything major on the roadmap that we can look forward to?
Yes, we have, but it's a secret. But I want to add something. We discussed a lot about, in our company, we discussed a lot about cloud, having products, having encoders for cloud. And we decided not to do it because most of the time our encoder has a fast information, needs fast information for the process.
Right.
So you would have a lot of information in the cloud afterwards. So most of all the time, we think that the information goes to the PLC or to the drive, and the PLC and the drive calculate, recalculate, concentrate the data to bring the right information to the cloud or to the SCADA system, whatever needed at this time.
They're more interested in maybe tracking energy usage in the equipment than where the position of the servo motor is at a certain stage of the process.
Yeah, if you go for predictive maintenance, you have the temperature or the vibration in the encoder and give some information back to the PLC. Now the vibration is exceeded, so the bearings of the motor is maybe not as good as before, something like this.
So another safety element there, or in that case, predictive maintenance type information. And since the PLCs and or the drives usually have communication interfaces built into them, does that allow you to maybe offer additional functionality without having to increase the price, like the NFC programmability and configuration? By offloading or using the PLC for that communication, does that help to further simplify and make a more attractive price point?
You mean compared to the to the NFC or not NFC?
More compared to if you had an encoder that was trying to send data to the cloud, for example.
Okay. Yes. Okay. Yes. An NFC is much less expensive in the costs.
Right.
What you could do is that for sure we have some information in our encoder, what we could send to the smartphone.
Right.
So how many counts already done, and so on, how many hours power on. So there are some data we could get out of our encoder into the smartphone and then also somewhere in the cloud.
Right.
The application is not ready now, so it works in our application,
so we got
but
one
the
future
customer.
Secret.
Yeah.
We got one future secret. We're just going to keep Robert on this podcast till he tells us the whole roadmap. We're just going to keep going around. So cool. So that's a different function that we might be seeing on your Prime. What's the name of the app, by the way?
What's the name of the app?
Wachendorff?
WDGA.
WDGA?
No, WDGN.
WG. What's the super secret acronym stand for? Tom, do you know?
So WDGN is the W is Wachendorff. The D is you put me on this one.
Drehgeber.
It's a German word.
Drehgeber. That's a German word. Drehgeber for encoder.
Encoder.
Drehgeber,
Yes, thank you,
encoder.
Robert. I was struggling for the German to English.
Well, maybe
conversion.
Robert should just tell us what the acronym means.
Yes, Robert.
Because it sounds like it's in German.
We'll pass that one to Robert.
Okay.
So what does it stand for?
What is that for?
Wachendorff.
Wachendorff Drehgeber.
Okay.
And W Wachendorff encoder.
Okay. All right. So
So it
the
would
whole,
be WEC would be the English translation, and N stands for NFC. So
There you go.
WDGN. I know W is not a very
I'm
easy
fond
word.
of W, actually. Win, first name
Yeah,
Win.
sure.
So, yeah, no, I like W. W is good.
yeah, and I like BMW as well.
I'm with you 100%. 100%. All right. So is there anything that we haven't covered today when we're talking about the different applications, or we talked about safety and how this, at lots of different levels. Safety for equipment, safety for large operations and user safety, not exceeding thresholds on the crane.
Robert touched on predictive maintenance, and I like to think we're at the spearhead of, the trends that are happening with data collection, the Internet of Things, our connectivity, getting data out of the device that then can be used on the plant floor and then passed on for further analysis and process. Sorry, I was distracted by the beeps, but I could take
That's
that.
all right.
I could take that from the top if you would like.
Why don't you do that, and then I'll do a close. But don't look at that camera, John, because it's off.
You want to ask me the question again? Anything else?
Yeah.
I can do something. I can add something
Okay.
about manufacturing.
So, gentlemen, is there anything else we haven't covered today that you think is
Yes,
important?
indeed.
Lay it on.
So stay tuned for developments in the direction of Internet of Things and data and connectivity,
Okay.
predictive maintenance. We like to think that we're at the spearhead of that development.
When it comes to encoders,
Correct.
and the fancy German word that goes DG that I don't know, but it means encoders.
WDGN, I will let Robert let you know what that is. It's a German.
Yeah, he explained it. I
German
know now.
acronym.
We're good. We're good. We're good. What do you think, Robert? What else haven't we touched on?
I think at the end, our encoders itself, they just make a job. So the best thing is nobody knows that's inside and it works.
Right.
Over decades and nobody take care. And that's the main job I'm responsible for. So if you have all these theories are important, but at the end, our customers would like to see a reliable product all the time over years.
Absolutely.
And that's
they want to be able to
what we
forget
stand
about
for.
you.
Huh?
They want to be able to forget about
Yeah,
your
they don't want to
component.
know me.
at least until they're building the next machine.
Yeah.
Anyway.
Then we are there.
Fantastic. Gentlemen, thank you so much for taking time out of your busy week to come down and spend some time with us and talk to us a little bit about encoders and how important they are to the general automation space. Remember, precision control means higher throughput, means happier customers. We've got lots of safety components that are built into this particular system. The near-field communication is definitely an inspiration, so I think that's just really cool with the fast configuration and reset, and reducing part count for spare parts and for simplifying supply chains for distributors who are having to support a whole bunch of different customers in different industries. You can have just a few different models that you can optimize for whatever new system or replacement part is needed. That's all good stuff. So thanks again for sharing it with us. I hope you've enjoyed this episode of Manufacturing Matters. If you've got any questions, please just send them below. We'll make sure we get them to Tom and Robert, or feel free to reach out to, what's our URL, guys? Wachendorff?
Wachendorff.com.
Wachendorff.com doesn't get any simpler than that. So feel free to go right to their website, check out some of the new apps and the encoder information that's on there. If you'd like to check in our old episodes, go to manufacturing-matters.com. If you'd like to be on a future episode, reach out to us, and you can find us on all your major podcast platforms. Thanks again for your time today, and look forward to the next episode of Manufacturing Matters.
Yeah, thank you very much.
Thank you.
Thank you.
Pleasure.